today in class, when I taught this video, I opened with this exercise where I give you this expression, ask you to label the variable and the coefficient, and then also find the square root of these two expressions down below. So please pause the video for a minute and complete the exercise. So when I did this in class, everyone got this right. And no one in the class got the coefficient right because people said 8. Right? They said that coefficient is 8. And I said, well, what about the 9? You know, what's going on with the 9 then? And in order to explain this, the coefficient is actually 8/9. Right? If I write it like this, and we just worked on fractions in the last lesson, right? And so this is like 8/1, 8/9 times x would be 8x/9. So the coefficient is actually, sorry about that, 8/9. Okay, not just 8. And so what I am telling students, encouraging students to try to get comfortable with is taking a variable with a coefficient and like pulling them apart. Okay, so that we separate the coefficient from the variable, then we can apply the rules that we have of exponents or, you know, whatever we might be doing, and then multiply the coefficient back in later. That's something that you're going to do a lot in calculus. But one of the things that I did in class also to help illustrate for students is I said, well, what's 10/2? Right, and everybody says 5. And then I said, what's half of 10? Half times 10. Right? So these two expressions, they don't look the same, but they are the same, right? They would have the same answer. And I talk a lot throughout the course, and I know I've started saying this phrase in other videos, about changing the appearance without changing the value. Okay, so over here, these two things look different, but they have the same value. Okay, right here, these two expressions look slightly different, but they both have the value of 5, and they both really mean the exact same thing. So anyway, moving on here, and I encourage you for this lesson to have your list of perfect squares in front of you and perfect cubes and all of those that we did at the end of the last video segment. But anyway, square root of 3 times 3, that's really saying what's the square root of 3 squared, right? And we should know that the square and the square root undo each other, right? So then this would leave me with just 3. Okay. Sometimes students say, wait a minute, what about all that plus and minus business? You know, my high school teacher made a big deal out of the plus and minus business. If you have an equation, x squared equals 9, the solution to that is plus or minus 3. Now, when you're taking a square root and the square root symbol, I'm sorry, I don't want a radical there. The square root symbol means principal square root. All right, so this would be the solution here. This means principal square root, which means only the positive value. So you should answer to all of these problems with the radical with only a positive. Now over here, you could multiply this all out and recognize that it's 81, and you know the square root of that. Or we recognize when we're taking the square root, right? Pairs, and I've had teachers say these like cute little sayings like, if it has a partner, it comes out front, right? So this brings the square root of 3 squared is 3. So that would happen twice. I'd have 3 times 3, which is 9. Okay, so the first part of this lesson then on the handout that I asked you to print involves simplifying radicals. And if you have good number skills, that would help you to recognize each of these are a product of some number with a perfect square. If you don't recognize that, that's okay. You can do a prime factorization and do a factor tree for 450 and 418. But I'm getting a little bit ahead of myself. Let me share this rule with you that the square root of a times b is equal to the square root of a times the square root of b. And I've already talked about this in the video where we talk about multiplication and how in multiplication we don't need like terms. So A and B are different numbers, but I can multiply them. Okay, now when it comes to addition, radical A plus radical B, right? Well, if A and B are different numbers, these are not like terms, right? And so I'm going to write next to this, I'm going to put NP for not possible. Okay, and so that's what we're going to say for, that's what I'm going to put on the answer keys when I post them. NP for not possible. There's nothing I can do there to simplify that when A and B have different values. They're not like terms. So anyway, what I can do here with this radical 50 is some of you probably recognize, oh, that's just 2 times 25, and 25 is a perfect square, right? So you could write it like this, and then, well, what's x cubed? That's x times x times x. And then, you know, anytime I have a partner, right, values with a partner, they come out front. And then I know the square root of 25 is 5, right? So 1x will come out front. And what is still left is the 2 is still under the radical, and so is 1x. Okay, if you didn't immediately recognize 50 as 25 times 2, and again, that is a problem of abusing your calculator, right? And I don't totally blame the student for that, because your teachers put that calculator into your hands at a young age and let you start using that calculator too often for too many basic facts, and then you never develop certain number skills. So if we do a prime factorization, right, and then we keep breaking this down until it's the product of primes, I can see that 50 breaks down to, so let's see, I'm running out of room here. I'll extend the page. No, new page. So this would break down to 2 times 5 times 5 times x times x times x, right? And then every time I have a partner, I bring it outside. Like that, okay? So that's where I get the 5 and the x on the outside, the 2 and the x still beneath. So you try letter A, simplifying radical 18. So you might have recognized, if you did a prime factorization, you'd get this, or you might have said, oh wait, that's just radical 2 times radical 9. And then what is radical 9? We know that's 3. Or if you did it this way, okay, we've got a partner, so they come outside, and we get 3 radical 2. Now, question number 2. So we've been working with this rule. Okay, and so I'm asking you, because again, what you see over here on the right is a very common mistake. I see this all the time teaching Calc 1. And again, it comes down to this, I can add things. I cannot add if I don't have like terms, but I can multiply if I don't have like terms, okay? Because again, say I had this. Say I started with this expression, radical 9 plus x squared, right? This answer would be 3 plus x, okay? But can I take these two things and combine them to get to here, right? And I can't, because for addition, I can't add unless I have like terms. Or another way to verify that this isn't true, but this one is think about what would happen if I came over and I squared both sides. Right? If I squared both sides, if I square the square root, I'm just left with what's underneath, right? 9x squared. And then if I squared the right-hand side of this, then I would also have 9x squared. Okay? But think about what would happen over on this side if I squared both sides. Okay, so this would leave me with 9 plus x squared. And we're going to review some of this algebra coming up. But I hope you recall from Algebra 2 that I can't just square 3 plus x by squaring the 3 and squaring the x. Many students try to do that, and it's incorrect. But this means to multiply it by itself, and this would require FOIL, right? Or there are some teachers who are opposed to calling it FOIL. FOIL stands for first, outside, inside, last. I don't have a problem with the term FOIL, but some teachers started saying, no, you have to use proper language, and we call it the double distributive property. But whatever you want to call it, the answer to this would not get you 9 plus x squared. Okay, so coming down in the exercises below, let's take a look at what we can simplify and what we can't. And then some of these problems, I think I'll circle it in yellow. Some of these problems are going to turn into the participation work. So this will be participation. Right now, please try A and B. And write NP for not possible, please. Okay, so letter B can be written like this, right? Since I can multiply these back and get here. Letter A cannot be written as x squared plus x squared, radical x squared, sorry, plus radical 16. Can't do that in letter A. So letter A is the not possible, the NP, whereas letter B would be 4x. Okay, so moving on to fractional exponents. And one thing that I want you to know about fractional exponents is, let's start with the very basic ones. And I always assume students know these, and I feel like that's probably not a safe assumption. So anyway, if I were working with something to the 1/2 power, oh, let me not use 2 because it's not a perfect square. So say I was doing 49 to the 1/2 power. If you follow the directions say the top number is the power. So this is saying 49 to the first power. The bottom number is the root. So this is saying take the second root, right? So if I raise this to the first power, it's just 49. If I take the second root, that's the square root. All right, so I expect you to know that to the 1/2 power is the square root. All right, to the 1/3 power is the cubed root. Okay, so this is saying the bottom number is the root, take the cubed root, and then raise that answer to the first power, is what that's saying. All right, but if I have other fractional powers, for example, so I'm going to fiddle with the same example here. What if I changed this to a 2? All right, and so what that means is take the cubed root, but then the top number is the power. So that means take the cubed root of 8 and then square it, or I could do this instead. I could square 8, right, get 64, square 8, then take that answer and take the cubed root. So again, these don't look the same, but they are the same, okay? This one is the better way to go because otherwise you get bigger numbers, right? This would give me 64, then I'd have to know that this cubed root of 64 is 4. But over here, this is saying cubed root of 8, right? I have a smaller number to have to work with. I would get 2 2 squared is 4. So let's go back to the handout. So I just did 8 to the 2/3. Is that even on my handout? No, 27 to the 2/3 is on my handout. So let's try 7. I'll do 7 with you. All right, so again, bottom number means root, top number means power. I really don't want to square 32 and then take the 5th root. I would much rather take the 5th root of 32. So I only had one number on your paper sorry, it's hard for me to write these square root symbols. That's why they look sort of funny there. I only had one number on the paper that I asked you to know 2 to the 5th power, right? So the 5th root of 32 is 2, and then I square it to get 4. Okay, so how about you try number 5, and then I'm going to circle these two for participation. So if ever in doubt, okay, so here you have to take the 4th root of 16 and then cube it. All right, if ever you're unsure of what the 4th root or 5th root or 3rd cubed root is, take the number and do a prime factorization. And since it's so cumbersome for me to write with my mouse here, I'm going to sort of cheat and jump in here and put it under the radical. Radical 16 is 2 times 2 times 2 times 2. Right? So if I'm talking about, oh, it shouldn't be a radical, it should be a 4th. If I'm talking about the 4th root, it takes 4 things to gather up to come outside as 1. Okay, so I have the 4th root of 2 to the 4th, which is 2. Okay, and then I have to cube 2, which will give me 8. Okay, the next rule involving negative exponents. And today in class, people did struggle with this a little bit. And I had a teacher in high school named Mr. Hopkins, and he used to always talk about, like if we were doing fractions like 8/9, he would always refer to numerator and denominator. He would just say upstairs and downstairs. And I actually liked that. I felt like that really helped me to understand what was going on. And so when we were working with things like this, Mr. Hopkins would always say, well, if there's a negative exponent, you bring it downstairs. Okay, it comes downstairs. And so this would result in 1 over 2 cubed. Now there's a formal rule, and you'll need this rule later on when you get to number 13 and 14. There is a formal rule that says that if you're working with a fraction to some negative power, that if you take the reciprocal of the base, then the exponent becomes positive. Okay, so that's the official rule. So if I applied this official rule to 2 to the negative 3rd, the reciprocal of 2 is 1/2, right? Change this to a positive power, which would be 3. But then I'd have to do 1 cubed over 2 cubed, right? Well, the reason I don't have a cubed up here is 1 cubed is just 1. So this rule will work, if you actually have a fractional base. But if it's just a whole number, I really liked Mr. Hopkins saying, do you really, you bring it downstairs. Right? And my husband also teaches math, and he says to me, do you really say upstairs and downstairs to your college kids? And I say, yes, I sure do, because I think it's a perfect way to describe that. So let's move on. So again, let me circle some things that you're going to do for participation. So for participation, you're going to do these two. And then 16 and 17, and I should tell you here that there are two answers for each. All right, two of these choices will be equivalent. Okay, so make sure you find both of them. So we're going to do 16 and 17. And then we're going to come over to 18. And the one that you're going to do for participation will be number 20. Oops, let me get my yellow. Okay, so that'll be the participation assignment for today. But I want you to write 18 and 19 with positive exponents. Or actually, no, let's just start with 18. Do 18 first, and then we'll talk about it, and then we'll move on. So in class today, I asked students, which is it? Right? Which one is the correct answer? I think more people voted for the one on the right. However, what I said back in the beginning of this video is please don't be afraid to take your coefficient, right? Separate it off from the variable. Okay, so pull that 2 right out in front. And I don't have anything to cover it with. When I was in class today, I was covering up the 2 with my hand, right? And I was saying, well, what do I do with x to the -3rd, right? Just like Mr. Hopkins says, bring it downstairs, right? And then we just finished our exercises on fractions in the day 1 video. Therefore, how do I multiply 2 times this, right? It's just 2 over x cubed. Because notice the negative exponent is only with the x. It's not on the 2 also. Okay, so the 2 stays upstairs, right? And then the x cubed goes downstairs. So now I have the quantity. Notice what makes 19 different than 18, right? On number 19, I have the 4x in parentheses. So take a minute and try 19. Okay, so which one is it for 19? Okay, does the 16 stay upstairs and just the x come downstairs? Or maybe a different answer. Maybe some of you have like 1/4 x squared. Or I think somebody in class today didn't know why the 16 was part of it, right? But what happened, so these might be possible answers that some of you tried writing. So what happened is this brings the entire quantity downstairs. So if I follow that rule, take the reciprocal of the 4x and then square that quantity. Okay, so the whole 4x comes downstairs because it was in parentheses, and so this would be the correct answer. Okay, so for the rest of today's time in class, I would like you to work on the circled yellow problems and submit that for today's participation. Thank you.